Hello everybody, I'm going to lecture dimensional analysis. It is chapter 7 of our textbook. In general, for any parameter that we have already discussed in this class, it can be classified in one of the three following items. It can be a geometrical parameter, for example, diameter of the pipe, length of a cylinder, or some others. It can be related to the fluid property, for example, density, viscosity, kinematic viscosity, and many others. Also, it can be a flow parameter. For example, velocity of the flow, volumetric flow rate, mass flow rate, and the rest. Please pay attention to the difference between 2 and 3. Fluid property just depends on the fluid by itself, not the flow condition. Whereas the third item is talking about the fluid in motion. Okay. We can combine some of those parameters together and group them in a dimensionless way. For example, a good example is this. If I have a rho V L divided by mu, 4 parameters are involved. 2 of them, rho and mu, are fluid property. V is number 3, flow property, and L is number 1, geometry. Then I can form such a group which is luckily a dimensionless parameter. It doesn't have any unit or dimension. This is called, for example, Reynolds number. And it is one of the famous dimensionless parameters that we have already talked in this class. These non-dimensionalizing has its own advantages. For example, for this one, Reynolds show the regime of the flow. If Reynolds is less than a critical value, the flow is laminar. Otherwise, the flow is turbulent. This critical value depends on the geometry. For example, for the pipe flow is 2300, and for a flat plate, external flow, it's 500,000. Okay, we can continue this approach and generate more dimensionless parameters. So one of them is this one. Say, for example, the second one that you might have seen is V divided by C. V is the fluid velocity, and denominator C is the local sound velocity. It says that how fluid is faster than sound. This is shown with MA, and it is called Mach number or Mach number, named after Ernest Mach. It is very important in aerodynamics, and for example, if Mach number is more than 1, it is called supersonic, and if it's more than 5, it's called hypersonic flight or motion. So this shows the compressibility of the fluid. Another one that I can generate is something very trivial. For example, any dimension, any arbitrary dimension involved in the problem can be dimensionalized by a characteristic length, L. So it is length ratio. The purpose of this example is dimensionless parameter doesn't need to be necessarily something very sophisticated, complicated. Just a simple non-dimensionalization works. For example, in a cylinder, you can non-dimensionalize its diameter to its length of the cylinder. Okay, there are some others that you might have seen or we will see in future. For example, one is recited here, P divided by rho V squared. P is the pressure, and denominator rho V squared is somehow pressure, which is very, very similar to dynamic pressure. This is called Euler number, EU, Euler number. It's another one. And if I change it very slightly in the denominator, I have 1/2 rho V squared. So the specific dynamic pressure, which you have already seen in Bernoulli equation, now appears in the denominator. It is called pressure coefficient. And let's show it with this symbol, for example, Cp, or coefficient of pressure. There are some others. For example, if there is any frequency in the fluid, I can say omega L divided by V. This one is called Strouhal or Strouhal number. So let me write it for you here. The correct spelling is Strouhal number, and it is denoted by ST. It is important when we have some vibrations, oscillations in the object or inside the fluid. One other one is, for example, rho V squared L divided by sigma. Sigma is surface tension coefficient. And this is called Weber number, Weber. You can see, for example, this dimensionless parameter when surface tension is important. For example, in bubbles, or when there is free surface in open channel. So for sure, we don't need to use all of those dimensionless parameters. And you have seen some of them so far, for example, the first two. You will see some others in near future, for example, a Strouhal number or Euler number. And the rest is just something that you might see in the context or not, depending upon what classes you will take or what area you will work in future. But the important thing is, first of all, you need to pay attention to make sure that the whole group is dimensionless, so you can check it. And second of all is, you need to know in what area, for what purpose, we can use these dimensionless parameters. So now I'm going to talk more about these things in the another segment.